I wrote the acronyms
So,
and the rules.
So basically knowing if it's a strong acid, strong base, or salt, right? Or an ionic compound is what she's, okay, so she said she's going to remember the acronyms and knowing just how to recognize that. That's cool. So that tells us if we have a strong one. What's another thing we can do? So we got 3 categories here.
Acids.
What was that?
Weak acids and weak bases.
All right, so knowing your weak acids and bases will at least tell you that it's not a non-electrolyte. Good. Okay. What else will tell you it's not a non-electrolyte? Or I'm sorry. What will tell you it's a non-electrolyte? What are you looking for on that one? What? Molecular. Is that what you just said? Yes. Okay, yes, that's right. So molecular compounds. So you're kind of asking yourself that. We also this morning added in, you have to ask yourself also, is it going to dissolve, right? But you can't stop at that question because what kind of... Sugar. Sugar ruins it. Sugar ruins everything. So, all right. So, the next part that we're going to focus on real quick, like dissolves like. So polar is going to dissolve polar things. Nonpolar will dissolve nonpolar things. I tabled this one in third, so I'm going to table it for you guys and come back to it tomorrow because I want you guys to practice writing it out correctly. Okay? Because if you say like dissolves like on an AP exam, they're not going to give you credit. You have to talk about how the positive and negative ends of the water molecule, which are polar, are attracted to certain ends. And so you have to have a polar thing to dissolve that one. Okay? But we'll put more emphasis on that tomorrow. So go ahead and turn the page. We're looking at molarity.
Wait, isn't our quiz tomorrow?
Mm-hmm. Yes, there is a quiz tomorrow. All right. Okay. What is that equation for molarity? Who remembers? That's right. Moles of what? All right. What goes into a solution? Solute. Yep. Okay. All over liters of... There we go. All right, cool. And it has to be in liters, okay? When you are writing your different molarity answers, or if they give you molarity, you can see it with a big M at the end. You can see that in brackets, like the whole number is just in brackets, no units at the end. Or you can see moles over liters, okay? And what I want to recommend to you is that when you get to your stoichiometry, try not leaving it like this, because that doesn't really help you in your railroad tracks or your setup, okay? This actually gives you a place to go, because now you can throw those units up or down, whichever way you need to do. If you want to take the inverse of it, okay? So all that stuff. All right, so the other one I want to throw up here is going to be your dilution one, because I didn't give you a spot to actually write that one. So we're going to also write our dilution formula so that we're ready for that. Your dilution formula, anybody remember that one? M1V1. I know, I got you. M equals M2, V2. Okay. And so this is the one where you have a stock solution on one side. So you have a concentrated version of it, and then you're trying to make a certain amount of a molarity. So you got to figure out usually how much, usually who you're solving for is this guy, okay? In pre-AP year, we asked you to solve for all of those, but it's really not normal for us to be like, hey, solve for this. Because I just want you to mix random stuff together and tell me what molarity you made, right? Like nobody does that. So you guys as AP, this is typically the one that you are always going to solve for, okay, whenever you're doing a dilution. All right, so let's go ahead and take a look at our first question. Okay, it says calculate the molarity of a solution that contains 0.875 moles of NaCl in 1 liter, and then 500 milliliters, 100 milliliters, 6 liters. So how many milliliters are in 1 liter? Just to make sure we got that. Okay, good. So since there's 1,000, what's the easy way to change your milliliters to a liter? What do you do with that decimal? 3 to the left. Okay? So you're going from this small thing to a big scale of that small thing, so it's a fraction of that big thing. Okay? All right. So calculate the molarity. So we're going to start with the easy one, which is 0.875 mole all over 1 liter. What is that? 0.875 molar. All right. It's nice to not hear calculators. That's good. It's a good sign. Okay. All right. 500 milliliters. So we're going to say 0.875 divided by 0.5. Good. What do we get for that one? What did you say? Oh, 1 point what?
75.
All right, there we go. So 1.75, and I'm going to go ahead and write my answer like this, so I know it's a concentration, which is molarity as well. Okay, just want you to get used to seeing that. And then the next one, we have 100 milliliters, so don't pull out your calculators for this one, please. Okay, because you got to be ready for your mental math on AP as well. Whenever you have that, how many times are we going to move that decimal? You're moving it once to the right, okay? So you should have 8.75, and then we're going to use moles over liters for that one. Then your last one, you guys can pick whatever you want. All right, so the last one is 0.875 divided by 6 liters, and that comes out to be, good, 0.146, and I'll put a big M again. Okay? All right. Are there any questions on how to use it? We're all okay. Sweet. Okay, so you'll probably never get anything that easy. Not good to know. All right, so what do you have to do when I give you grams instead? Because there's not some special scale out there that's like, let me measure moles, right? So what do you have to do first? You have to change it to moles. So you're going to do a quick gram to mole conversion. Instead of setting up railroad tracks, how can you do this quickly? Right, you divide by your molar mass. Okay? So make sure you don't forget to do that. And then you might be able to, when you're solving for molarity, right, and they want you to work backwards, you're just going to convert to grams by multiplying by the molar mass. So be ready for that little conversion there. We're all good to move on? Okay. So I want to look down here because the next question is kind of based off of this. All right, number 3 is based off of this. So this is down at the bottom left of your page. So preparing solutions, okay? You have 2 different things that you can do. You guys in this next lab will be doing this. Yeah, no, because I'm going to give you this one already done. You guys are going to prepare it from solution. So you do need to know how to do this. I will be asking you for steps on the exam for both of these. So this is something to study. Make sure you're elaborate and stuff, okay? So what you want to do for this, from a solid, you're going to measure out the solid in grams. Okay? You're going to place into a volumetric flask. Do I have the, okay. Does everybody know what a volumetric flask is? So the one that's on that counter way over there, that's an Erlenmeyer flask. This one right here, this is your volumetric flask. Okay? The reason why this one's special is this one has an etch on the top. Those are like painted on glass, right? This one actually has an etch, so this is supposed to be more accurate than those flasks. Okay, so you actually have to get the water to this line. It only measures whatever it tells you it measures. So this only measures 1,000 milliliters. So this is a liter one, okay? And we go all the way down to 100 milliliters. So, okay? So you want to use a volumetric flask. That's a key word, I would say. All right. Then you want to fill up your volumetric flask halfway with deionized water. Okay. You're going to swirl the mixture. Swirl until mostly dissolved. As long as it's not a very saturated situation there, you should be able to dissolve all of it. Okay? All right. Okay, so swirl until mostly dissolved, and then you fill to the line. With more DI water. Okay? You don't have to necessarily include this. If you want to, you can, but after this step, what you would usually do is you could either put a little stopper on this and kind of just go like this. Okay, just kind of go back and forth like that. I don't like to do that because I always feel like it leaks out, and so I don't trust the stoppers. So what I do is I usually pour it into a big beaker, and I just transfer it back and forth between beakers. That's usually what I do. It's a good way to mix it without, you don't want to shake it. Don't ever shake it. I obviously can't get a stirring rod in there, so it always makes me feel more confident that it's all mixed up. Okay? All right, cool. We'll come back to from solution. No, let's just do it. Let's just write it out. We'll make it's 3 steps. It'll be quick. All right, so remember from solution, this means that you're doing a dilution, okay? So this is that M1, V1, M2, V2. Okay? All right, so you're going to measure out the appropriate milliliters of stock solution. I guess I should say volume. If you forget the word stock, by the way, you can always say the more concentrated solution. Okay? Whichever one you're trying to dilute. Put into a volumetric flask. So there's that volumetric flask business again. Okay? Fill to the line with water. Okay? And once again, especially with these, you don't want to assume it mixed it as you were pouring it in. You do want to make sure with this one you kind of do this since there was no swirling involved in there. Some people will add halfway again, keep swirling, and then add a little bit more. But the big thing is you only want to go to the line, and that's why these guys are so important. Okay? They have it exact. Okay? All right. As long as we are good to move on. Let's go ahead and look at number 3 then. So number 3 says, how would you prepare 500 milliliter of 0.05 molar solution of that? Okay, so we're not going to rewrite those steps. Don't worry. Okay. So what we're going to do is, what? What do you guys think? What are we solving for here? What is 500 milliliters? Volume. What is 0.05 molar? Molarity. So who are we missing? Moles. You guys got that? Because what can we do then once we get our moles? We can turn it into grams, and now you can start your process, right? You measure out your grams, put it in there, swirl, swirl, all that good stuff, okay? So the big thing is we're trying to get to grams, okay? So we're going to take our molarity, set it equal to moles over, yeah, 0.05, wait, oh, 0.5. You were saying the other one. Okay, got it. Now I understand. All right, and how do we solve for a number on top? These guys are getting multiplied. You're multiplying them out, okay? All right, so when you multiply those two, you end up getting a number. Oh, you get 0.0250 moles. Okay, but that's not the answer. We now want to change that into grams, right? So we're going to say 0.0250 moles, and we multiply it by its molar mass, right? Because technically this would be a 1 mole, 2 grams. So the molar mass, just because we're running out of time, 187.55. Okay? So you would get 4.69 grams. And then you would use those little things that we wrote down there. Okay? Are there any questions on that? No? The next one is a dilution one, I think. So let's go ahead and do that one, and then we can pack up. Okay? Okay, so number 4 says calculate the volume of that needed to prepare 250 milliliters of a 0.04 molar solution. So, which one of these molarities is the one that we are making? It's the ones that we're making.
The first one.
It's the second one, right? This is what you're making. So basically, this would be like me reading through a lab that I'm going to do for y'all, and I'm like, oh, okay, I need to make sure I have this solution made. I have this over in the storage room. That's what we're doing here, okay? So this would be your stock solution, and that's why we need to know how much of that do we need to dilute it to 250 milliliters, okay? All right, so I would say my M1 is 0.500 molar. This is my M1. V1 is always usually who you're solving for. M2 is going to be 0.0400 times 0.250. Now, do I have to change that to liters technically on your dilution questions? Nope. If you are not solving for molarity, it doesn't matter, because these molarities, once you move this guy over to divide them over, those molarities just cancel each other out. So who cares, all right? The liters isn't necessarily necessary. But if you want to just keep yourself in good habit, always put it in liters, and then you can convert back to milliliters after, okay? So I'm going to keep going. When you do this, you now are going to have those numbers on top. I'm just helping the people out who don't know how to do this, and that's okay. You will learn, hopefully quickly. Okay, once you type that in, you should be getting 0.0200 liters, which is equal to how many milliliters? What is it? 20, right. So we're going to move that 3 to the right. So you have 20 milliliters. And that's it, okay? So you would take that little 20 milliliters, put it in my volumetric flask, fill up to the line, swish, 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 you have a solution, okay? You guys will have to make your own solutions for this next lab, so make sure you are going to come in knowing what you're doing. Because if you screw up your solution, I can't help you. I'm just kidding. We can just redo it over and over until you get it right. All right. For tomorrow, make sure you look over your solubility rules. That's what we're doing for most of it, okay? Ooh,